Good evening, everyone, and welcome to our first live project presentation on YouTube channel. And tonight's topic is Preso presentation, Preso project presentation, and we will talk about it with three speakers, three members of the Preso development team who are here with me tonight. There are some more behind the scenes, but we can't see them, but they are there. And tonight I have here with me Attilio Mandola, who is IoT specialist and head of a Steamport IoT lab situated in southern Italy. Then I have Giuseppe Angri, who is our talent full stack web developer and master student in computer science. And finally, I also have from Latvia, Emils talent front-end web developer and IT project management master student who is about to graduate. So before giving the floor to our speakers, I also want to tell you that you have the possibility and the opportunity to write some questions, to type your questions, if any, at the end of the presentation. So here here in the box on the right, you can see them. And at the end of our presentations, our speakers will be there to answer to your questions. So before going into detail about this presentation, I want to tell you, to introduce what Preso is. So for those of you watching, I'll introduce you to this project. So I'll cut to a very brief presentation for you. Okay, let's see. You should be able to, yes, to see what Preso is, how it looks like. So Preso is, as you can see, here are listed some of its features. But Preso is an IoT smart device, hackable. It's a smartphone plug that allows you to control any of your plugged-in household devices' performance and to actually monitor your home power consumption directly from your smartphone wherever you are. We want to say that also this smart device evolved into a smart outlet, assuming that automatic control of your household appliances behavior thanks to the Preso app. Giuseppe Angri will tell you more about the development of Preso app. So we will go in detail later. So now how it works, as you can see in the picture of this slide, Preso works in a network of connected Preso devices that steadily monitors the energy consumption of each connected device along with its app. Should one instantly absorb too much energy, Preso will disconnect at once the lower priority devices so as to let the whole system keep on running. Just a few words on the Preso app. Here you can see possible scenarios where you can actually use it. Of course, nowadays no hardware exists without software. So we have this Preso app, which is very easy and intuitive to use, and it will allow you to run your home appliances, of course, on the go at a tap as we are used to actually. And what's more, you can customize your home appliances behavior at your ease, at your fingertips, as we can say today. So so it's easy for us to remotely control their status, even when we are not at home, even when we are out and about. So possible scenarios, what can be? They can be like the possibility, the opportunity to turn on our lights before coming back home from work, or turning on our warm heater for a shower before coming back, or in the morning as we wake up, switching on our coffee maker. So it's very nice. So now let's hear what Attilio, what was his role in this project, within this project. Please, Attilio, tell us how do you developed your hardware?
Hi to all, I'm Attilio. I'm the responsible of the device development in the Preso project, and today I will talk to you briefly about the Preso device. Yes. No. Okay. Can you see my presentation, right?
Yes.
Okay. This is the Preso device, and this is now a smart outlet. Externally, we can recognize the socket where you can connect to your appliances, the plug where you connect the device to the power. We can see an OLED display where user can read information and change settings, along with two push buttons to let him interact with the device. The project started with these requirements. Other requirements were that we need to power the device directly from the network power. It has to be Wi-Fi enabled, Internet enabled, to be able to communicate with the app. It has to have precise and fast current sensing to know how we are consuming with our devices or appliances connected, and to also monitor the overdraw current in our houses, so we can maybe shut down most demanding appliances to use other appliances connected. It has the capacity to support the common current draw, or maybe big appliances like ovens or air dryers. It has to be reasonably cheap, to be bought in numbers, so we can connect every device in our homes, and easy to use. For software requirements, we needed also fast current sensing, a fast machine-to-machine communication, because Presos will communicate each other to exchange information on how the network state is. He has to have a reliable server connection handling, reliable data collecting and sending, also easy to use, and he has to be updatable over the air, so the user can update the firmware in case there are updating or improvement to software. So, Preso is composed by four main components. At the core, there is an MCU, specified an SP8266, that is Wi-Fi capable itself and has as much processing power as we need. The other main components are a current sensor, responsible of power detecting, and a relay switch uses to shut down or enable connected appliances, and an OLED display to show infos and used by user to change settings on the device. We had some hardware interactions in our development process. We had the proof of concept prototype that was just a prototype to test the technologies we want to use. And then we moved along with the dirty prototype, also on a breadboard, so just wires through to breadboard and very dirty and messed up things, hardware. And then we passed to a true hole and perforate prototype, so soldering irons, wires through all components, just to test if the device can work as we expected. Then we made a custom in-house PCB. A PCB is a printed circuit board, so a circuit like you can see in your electronic device if you open them. And then we iterate in this way. So we went through this PCB prototyping process, and then we choose to use a third-party hardware like the son of POW and so on. And then we made the final prototype that we presented in the Kickstarter campaign. We used electronics CAD to design PCBs. Then we milled them on a CNC router, and then we perfected this task by etching them with a bromograph and chemical process. For the case, we used a 3D modeling software, in this case Rhinoceros, and a 3D printer to have a fast iteration on case on case like in this slide. We can see various iteration of the external case. As the software, we also had some iterations, and the first software was just a proof of concept software for part testing. So we had like oscilloscope connected, and then test things to test components. Then we tried with MicroPython, a MicroPython firmware on the device, and iterated that. So at the last, we changed it with an Arduino IDE version. So it's just C code compiled in the Arduino IDE. And we perfected that to the final Arduino IDE version that is hackable and is customizable by user, by maybe power user, skilled user. And Preso communicates with the server over the internet and uses MQTT and UDP protocols. The first protocol we tried was COAP. That is a very light protocol, but it has some limitation, and we had some problem with it because we can't use it in our app. And then we like hybridized that with MQTT, that is a gateway and broker-based protocol. So it's centralized in our app, and devices can communicate to it by subscribing or publishing to the topic. And then we dropped COAP in favor you have a light UDP messaging protocol, and then devices will communicate through each other with UDP messages. MQTT is still used to communicate with the server, and the communication is follows this pattern. Power is collected through the socket, and then is calculated by polling the current sensor, and values are then interpolated by the MCU. Values are then encapsulated in a JSON format, along with the timestamp obtained by the NTP server, and published in the device MQTT topic. Then the app is later responsible to collect the data and store them in the database. So I am brief, as I promised you. So thank you, and I give the word to Filomena.
Yes, thank you, Attilio, for showing us a brief overview of the hardware requirements, software requirements, all the communication protocols, and all the process you went through in the development of the hardware of the smart device, Now I give the floor to Giuseppe, who will tell us about something more about the Preso app, the software, and all the technologies implemented while developing it. Please, Giuseppe.
Hi all, my name is Giuseppe Andri. I study the master's degree in computer science at the University of Salerno, and I'm having a part-time collaboration with the Like a Coffee community since 7 months. I worked on internal project Preso as a full-stack web developer, and in this presentation I will show you a summary of Preso software development. I starting with the description of the architecture of entire system, and then I will show you the technology stack used in each part of it. As you can see, this is a high-level diagram of the system architecture. There is a single database that collects all data coming from the Preso databases and from the common features of the apps, such as user information, electrical device, network, and so on. Then there are two backends. The first is reserved to the IoT devices. All Preso devices communicate with this backend to get the configuration and to send the collected data. Happens through MQTT protocol. The second is the main backend. It provides the API for all feature offered in the admin web app or in the end user mobile app. Both backend communicate with the same database. In this way, we can have this scenario. A user sets the Preso configuration from the mobile app, and this configuration will be saved in the database. The Preso device gets this configuration from the same database, and the Preso collects the data and saves it always on the same database. In this way, the user can finally choose this data from the app. Now I'll show you an overview of a technology stack used in this project. For the database, we use MongoDB. For both backend, we use Node.js as application server with the help of Express framework. Then, as for the front end, in the admin web app, we use Angular as JavaScript framework together with Less as stylesheets precompiler. Then we use Angular material as a style library, so we can have some components already in progress, and Grant as a task runner. For the mobile app, we implemented the same technology stack, save for Apache Cordo, a framework that we used for the building of the mobile app on both platform, iOS and Android. We can see it later. Then, with respect to the third-part technologies used throughout the project, we used Git as a code versioning, Heroku for hosting the database and both backend, and finally Auth0 as authentication provider. Now let's move on backend focus. At first, I show you the folder structure. Starting from the root directory of the backend, we have some folders that are common for all features, such as config. Then, for each feature, we have a separate folder. As we can see in this slide, we have electrical device invitation or Preso feature. And each of this folder contains all related file. This approach is called folder by feature. Now, for each functionality, I show you all related file. Let's take electrical device for example. We have the model file, the helper, the controller, the middleware, and finally the roots file. Now we go through them more in detail. Starting from the model, for each feature in this file, we specify all fields, and then we export the model through Mongoose library that helps in managing of the MongoDB collections. The helper instead is the sole file which uses the model mentioned before. Here we have a list of functionalities with the purpose of managing the data for this feature. In this slide, I just show you the index function, where we use the electrical device model, as we can see from this function, to find all data, to populate the foreign key, and to execute the query. Then we can get the result. Then I pass to the controller, which is the sole file that requires the helper file mentioned before. As we said earlier, the helper file uses directly the model. Instead, now the controller recalls the helper functions. Its functions are the final API. In fact, as we can see in the index function shown as an example, we have the request and response objects coming from each HTTP request. The middleware is the file that contains some checks designed ad hoc for certain API. In this example, we can see the middleware executed prior the controller function of store image API, always for electrical device feature. Here we have only a simple check to check if the electrical device exists or not in our database. Finally, we have the file that contains all routes of this feature. In this example, always electrical device. As we can see, at first we import the previous middleware's controllers all required for this API. Then at first we create a router group for all endpoints that contains the prefix of the current feature. Then inside the group we declare all other endpoints. For each endpoint we set the HTTP method such as get, post, or put, the path, and the list of functions to be recalled. Staying on the backend, I now explain how the authentication is managed. We use two types of token. The first one is a simple JSON web token, admin web app. The second one is provided by the Auth0 provider. As I said before, Auth0 is used to manage the user and the authentication from our mobile app. As we have two types of token, we felt the need of developing a backend middleware. The latter intercepts all HTTP requests sent to the backend and parses the token to get the authentication information, the authentication user information. Here I listed an overview of Auth0 provider functionalities. It is an authentication platform for developers. It allows you to use social providers such as Google, Facebook. It provides you reporting and analytics service. It has customizable single sign-up pages. It provides API and software development kit for web, mobile, and native platforms. Finally, it is extensible and allows you to integrate other services. Here, it's a brief overview of social providers offered by Auth0. As we can see from the left, in our application, we use only Facebook provider. And on the right, we have a screenshot of our application login page with the Facebook possibility or email and password login. Another interesting functionality that I chose to show you is the Auth0 rules. These rules are functions written in JavaScript which allows us to extend and customize our service by using Auth0 software development kit. Now we skip to a brief front-end focus. As for the backend, I show you the folder structure. Starting from the root directory, we have the common folders like component and services that are common in whole application, in the entire application. Then for each feature, we have always a separate folder that contains a related file. For each functionality, such as for electrical device, I show you all related file. We have the Angular module file because each functionality is an Angular module. Then we have the Angular factory that allows us to communication with the backend, and finally the routes. Furthermore, for each page of the application, such as the list of electrical device or the page to add a new electrical device, we have another separate folder with related file. Let's take add electrical device page for example. Here we have the Angular routes file, the Angular controller, the HTML view, and the less style sheets file. Finally, as for the front end, in this slide, I explain you the tools used to build the mobile app. The core is Apache Cordova that compiles the code to build the iOS or Android apps. Whereas Grant is used to execute several tasks, such as cleaning, optimizing JavaScript codes, compiling less style sheets, serving application in our web browser and watching for changes, and finally to building and running application with Cordova. From my side, it's all. Thanks for your attention.
Thank you, Giuseppe, for sharing with us and with all the community your experience and really technical software development of the app and all the technologies you used together with the other developers and our mentors. And finally, I want to give the floor also to Emils Bemberis, who will tell us his experience as a project manager and developer. He worked on Preso for his internship. So I'm actually curious to know, and I hope everyone is curious to know what his experience was, what he can tell us about the tools he experienced also within the work team. Please, Emils, the floor is yours.
Yes, thank you, Philomena. My name is Emils. I'm a junior developer in the Like a Coffee community, and I'm gonna introduce you how project management was done in Preso project. Let me set my presentation. To develop our project, we needed to assemble a team, and of course we did. Our project managers were Antonio Torre, Janos Uivari, our designer was Giuseppe Rivello, and our developers were Attilio Mandola, Luigi Cutolo, Giuseppe Angri, and me, Emils Bembers. We all work remotely, and there are some pros and cons in that. For some of us, that gives a chance to combine work with university, as it was also in my case. And for others, it allows them to plan their work schedule so that they can work in their most suitable time. But as we all are working remotely, one of the challenges is communication. Communication is the key for a good teamwork. And for our team communication, we used Slack and Google Hangout. Slack is a messaging app for teams. It brings communication and files in one place where they are instantly searchable and available for use. Slack offers features like chat rooms, channels organized by topics, as well as private groups and direct messaging. All content is searchable, including files, conversations, and people. We used Slack for day-to-day communication, where we would ask questions to the team, share our opinions about project development, and generally just keep in touch with each other. Google Hangout is a communication platform developed by Google, which includes instant messaging, video chat, SMS, and voice over IP features. We use it for our video meetings. We took those roughly 2 times in a month to discuss some topics which needed quicker solutions, and also it was just good to see each other. To manage our workflow, we used project management and issue tracking tool called Redmine. Redmine tool allows to manage multiple projects and associated tasks, create work items, and enter the time tracking for them. As other features, it also includes calendar, Gantt charts, visual representation of project under deadline, flexible role-based account control, and allows simple time tracking. And we kindly took advantage of all those features. We created the project file with it, we added work items there, did the time tracking, and organized multiple sprints. As Giuseppe already mentioned, we used Git as our source code versioning system. It allowed us to work simultaneously on the same project, pull other developer changes, and push our own changes to the source code. And we used Heroku to deploy our app. To help developers to better understand the requirements of the project, for our mockups, we used MarvelUp. MarvelUp is a design prototyping tool. With MarvelUp, you can easily create a prototype for an app or website design. It provides the developer an opportunity to test both user interaction and user experience before jumping into the app or website build. It helped our developers greatly because it allowed us to see how our designer had pictured the Preso app, and we could play around with it before it was even built. I joined this project development relatively late while undertaking my internship. And when I took my part in this project, I already had experience with remote work. But the communication tool Slack and project management tool Redmine was something new for me, but I quickly got a hang of them. I had to grasp what was already done in project development, and at the beginning it was a bit overwhelming. The project was coded in a programming language that I hadn't worked with for some time, and new team members with whom I hadn't worked before. But I learned how to work with Angular 1 again, got familiar with project structure, and I could contribute my share of work in this project. And it was easy to work with other guys. They were very open, easy to talk, and quick to help with questions I had. They are a group of smart and talented people, and I really enjoyed working with them. What I learned from the project management point of view was the new toolset that could be used to manage the project development. I think that Like a Coffee has found a nice combination of them. Slack as a communication bridge, Redmine as issue tracking tool, Git as a way to share work on the project, and MarvelUp as a beacon to developers. Together, they help to overview and develop the Preso project in an easy and transparent way. And with that, I want to say thank you. My name was Emils, and I hope you enjoyed this presentation.
We did, at least me, I did. And I really hope that you got the most out of this experience, both on the development side, on the project management side, and on the human side, because also it was within a remote team, because with all the issues and the nice things that this entails. So let's see if there are, so thank you, Emils.
Yes.
So let's see if there are some questions from our community members, if someone has something to ask to our three speakers. Let's wait maybe a few minutes if some questions should arise. I remember that I remind you all that if you have some questions also arising later or in the next days, you can always post them on our Facebook closed group where all of you are, and don't be scared, don't be shy to post if you have something to ask or some curiosity from all our speakers, and also if you have something to ask us as talent managers, or also to mentors or to our designer. So let's wait some moment to see if there is something arising. Okay, see, we see that there is someone who is writing, is typing. Also comments, it's not that you have to ask questions. You can ask questions on IoT or on some technologies, or how was it the experience with Slack?
Milo, we have consideration and question in chat live on YouTube.
Okay.
Yeah, I'm seeing that. So he's asking to all us what's the biggest challenge for us to face.
Okay, why I can see it?
First,
I can.
Maybe.
Where shall I go to see it?
Yeah, I can respond.
Okay.
Okay. For me, the biggest challenge was to pass by a mere prototype and maybe a functioning thing, a functioning device, to a product. So something that can be used by anyone, anytime, and is for a real user that is not technically skilled and is not the way to maybe push things or attach wires and so on. So this is for me the scariest part, because there are so many variables in that, and it took a very long time to figure out what are the issues that can be arise in the process. What are the troubles a user can experience, because it requires a lot of testing. A lot of experimentation, a lot of also precognition in sometimes. So for me is the biggest challenge I had in this project. So I give the word to you guys. What you think?
Yes, for me the biggest challenge, I would say, was to learn the structure of the project, because at the beginning it seemed really difficult to understand, but yeah, in time I get to know it, and I think I'm now familiar with it. Yeah, that's
from
it from
my side. Okay, from my side, the first challenge is the communication, because it is my first remotely working experience. So the communication, as said from Emils, is very important, and it's the main part to manage the works and go on together. And as a second challenge, I can tell that the works with an IoT devices, and also with a team as like a coffee that contains several people with different skills. So we have to work with a developer, software developer, or IoT developer, or graphic designer. So it's a challenge to work with several people with different skills. It's all.
Okay, thank you for your answers. I hope this curiosity was fulfilled. Let's see if there are some other questions. If there are, I ask the director to tell me, because I still can't see them.
At the moment, we have.
Okay.
Maybe we can close and continue.
Yes. Okay, so let's stop here. If you have some questions later in the next days, as I said, you can post them on our Facebook group. So I thank my guests, my speakers here. I thank my director there, and all of you, of course, for watching us tonight. So have a nice evening, and until next time.
Have a nice evening. Thank you. Bye.
Yes, thank you. Bye.
Thank you all. Bye.